Goedenavond iedereen, welkom hier in M. Fijn dat jullie hier zijn voor deze denkvoeravond in het kader van Dusty Die, de solo-tentoonstelling van Alicja Kwade. Alicja behoort tot een van de invloedrijkste kunstenaars van haar generatie. Ze staat bekend om haar sculpturale installaties, waarin ze filosofische en wetenschappelijke ideeën tastbaar maakt. En waarin ze ook speelt met perceptie, tijd en materie. Jullie hebben allemaal de tentoonstelling wellicht al gezien. Haar werk was wereldwijd, of is wereldwijd te zien en dus nu ook in M hier vandaag. De tentoonstelling is ongeveer halfweg en is ontstaan ook in samenwerking met de KU Leuven in het kader van 600 jaar viering KU Leuven. En in die context hebben we een lezingenreeks gemaakt van 3 wetenschappers die we hebben uitgenodigd om vanuit hun expertise te reflecteren op haar werk. Niet om haar werk te verklaren, maar om ermee in dialoog te gaan. En vanavond staat 1 grote vraag centraal. Wat als tijd niet is wat we denken dat het is? Daarover gaat cosmoloog Thomas Hertog straks in gesprek met Alicja Kwade. Thomas Hertog werkte jarenlang samen met Stephen Hawking en onderzoekt hoe tijd geen vast kader is, maar een eigenschap die mee-evolueert met de structuur van het universum. Die ideeën vinden een sterke visuele tegenhanger in het werk van Alicja Kwade. Ook in haar werk is tijd niet lineair, maar gelaagd, onzeker en afhankelijk van het perspectief. Het gesprek vanavond wordt gemodereerd door Marc-Olivier Waller, curator, kunsthistoricus en directeur van het Musée d'Art et d'Histoire in Genève. Hij werkte al meermaals met Alicja samen en kent haar werk heel goed. We zijn heel blij die 3 stemmen hier vanavond te mogen samenbrengen, samen met een mooi gevulde zaal. En al die achtergronden samen te brengen, om samen na te denken over wat we weten en wat we niet weten. Ik wens jullie een hele fijne avond. De rest van de avond zal in het Engels verlopen, zoals jullie begrijpen. Ik geef heel graag het woord aan Thomas.
Thank you, Eva. It's a great pleasure to be a warm-up act for Alicia and Marc-Olivier. So, Alicia asks, what if the unknown is not a boundary, but a starting point? Alicia, in her wonderful exposition, challenges our certainties. She challenges who we are in this vast time and this vast cosmos. I think fundamentally she asks us to ponder, well, what is our place in the universe? And, well, I'm a scientist, I myself am a scientist, I'm a cosmologist, I'm interested in deep space, deep time, and for me, the unknown is also a starting point. In fact, it's the starting point. We often think about science as providing answers, but I can assure you that in my experience being a scientist, most of the time it's about not knowing, it's about doubt, it's about imagination, it's about questioning our certainties. So I feel a close connection to Alicia. Now my own trajectory into the unknown started about 25 years ago, or at least that's when it got some grounding, when the celebrated cosmologist Stephen Hawking invited me to his office. He wanted to discuss the Big Bang. That was his idea of a job interview. And so this is pretty much how I found him in Cambridge, locked to his wheelchair, as many of you will know, and surrounded by everything that a theoretical physicist at the time needed. Lots of books, a dysfunctional desktop, and a picture of Marilyn Monroe on the wall. Now, Stephen had already lost his natural voice in the 90s, but he could talk through a computer voice, which was mounted on his wheelchair, which he directed with some sort of old-fashioned mouse, which a nurse carefully placed in his hand every morning. And this is what he asked me during that first conversation in Cambridge.
The universe appears designed. Why is it the way it is?
So, good luck with your next job interview. When Hawking ponders the design of the universe, what he means is that it's not so much about life as such. It's really about the conditions that make life possible in our universe. When we look out into space, you see, we find a strangely biophilic universe. We find a universe filled with atoms and organic molecules and clouds in which new stars and planets are born. But all that is the result of 13 billion years of cosmic evolution. That cosmic evolution has been governed by what we call the laws of physics. It's at the level of the laws of physics that the enigma of the biophilic character of our universe is truly mind-boggling. And the reason is the following. If you were to change the laws of physics just a tiny bit, the habitability of our universe would disappear. If you were to change the composition of the universe, or the types of particles, or the particle forces, just a tiny bit, our universe would no longer be fit for life. And so Stephen asks, what should we think of this? It is, strangely enough, as if the universe has known all along that one day it would harbor life. So this is the modern scientific puzzle, the modern scientific riddle of, well, ultimately, where do we come from? What are our true or deepest origins? And I was reminded of this design question in cosmology, when I walked through Alicya's exposition, and I saw her work, Super Heavy Skies. It's some sort of delicate solar system kind of upside-down construction, which if you wiggle it just a little bit, Alicja just explained to me, it falls apart. So it's delicately fine-tuned. Well, that's our universe as well, but at the level of the mathematical equations, the mathematical laws of physics behind it. Now, I should warn you, the fact that our universe at the level of the mathematics underlying it is mysteriously biophilic does not mean that it's full of life everywhere. It's just the basic conditions are right. But actual life, advanced life forms, may well be short-lived. In fact, in the back of this picture, there's another work of Alicja, which is hanging there, which is a list of asteroids which could destroy life on Earth. And indeed, life could be short-lived on a cosmic scale. We could destroy ourselves, or we could be destroyed by asteroids, and so forth. But the basic conditions seem to be very finely tuned. So, to make some progress on Hawking's question, I have to explain you a bit where these laws of physics, what should we think of these, where do they come from? And the first person to really enable us to get a grips on cosmology, sort of the birth of cosmology, goes back to Albert Einstein. This is incidentally one of the rare portraits of Albert Einstein by the so-called Einstein painter, the Belgian Alphonse Blomme, who painted Einstein when he was essentially a refugee in 1933 in De Haan, in the near the Belgian coast. Einstein rethought gravity. Alicja also likes to rethink gravity. Alicja also likes to rethink time. But Einstein rethought gravity and time and space his own way, in a different way. Einstein did it by writing down an amazing equation. Here's Einstein's greatest equation. It's his theory of relativity, with which he dethroned Newton as the father of gravity. Such a mathematical equation is all in all easy to read, right? As you can see, it has two sides. On the left-hand side, there's a mathematical object that represents the structure of space and time, the structure of reality. On the right-hand side, there's a mathematical object that represents the stuff inside the universe, planets, stars, galaxies, and so forth. And of course, the magic of Einstein's equation is the equal sign in the middle. That's one of the most baffling equal signs in 20th century science. It tells us that the shape of reality, the shape of the universe, the structure of space and time is in fact not an abstract metaphysical thing, like Newton would have it, but is determined by what's on the other side of the equation, the stuff inside the universe. And so, according to Einstein, this is how gravity works. The mass of the Earth will slightly deform the fabric of space, and that deformation will create a valley, and it will keep the Moon pretty much automatically in orbit around our planet. Likewise, the mass of the Sun will keep the Earth and all the other planets nicely in orbit around it. So, in a sense, Einstein's theory makes alive the notions of space and time. They're no longer metaphysical, static arena. No, they're part of physics. They're physical fields that can change and evolve. So that's all fine. But the problem came, as often is the case, the problem came from Belgium. From Leuven, in fact. So here's Georges Lemaitre. And Georges Lemaitre was a little younger than Einstein. He learned about Einstein's theory while at a seminary studying for priest. And Lemaitre said, wow, here we have for the very first time in the history of mankind an equation, a scientific theory with which we can say something about the universe as a whole. Lemaitre put all the matter on the right-hand side of the equation, all the galaxies, all the stars, and he moved to the left-hand side, to the shape of space side. And to his amazement, he saw that the universe could not just stand still. Going forward in time, the universe had to expand, space had to stretch. Going backwards in time, the universe had to shrink. And so Lemaitre took Einstein's equation and evolved our universe backwards in time. He arrived at some moment that space was shrinking all the way back. There was a moment in the past in which the fabric of space destroyed itself. And that was the Big Bang. That was the discovery of the Big Bang. So the Big Bang is not an explosion that exists in a universe, that happens in a universe that already exists. No, it's an origin. It's the most fundamental origin that you can imagine, and then still a little more fundamental. It's the origin of space and time. Now, what do you do when you discover the Big Bang? Lemaitre was a priest, so he couldn't tell about it to his wife, and he could not tell the Pope either. But of course, he had to tell Einstein, and he did. Lemaitre and Einstein met in the margins of the famous Solvay conference in 1927, and as you can see, the conversation didn't go very well. When Lemaitre explained to Einstein that his new grand theory of relativity predicts that the universe had a beginning, Einstein replied that his calculations could be correct, but his physical intuition was essentially rubbish. And of course, it did not help that Lemaitre had his clerical collar firmly in place. Why did Einstein not agree? Well, Einstein was an idealist. Einstein was essentially the first one to really begin to think about the ultimate theory of physics, the final theory. Einstein's answer to Hawking's question, what's the root of the design of the universe? Einstein's answer was, it's got to be written in the mathematics. The universe has to be like that. It's a mathematical truth. So he was looking for that. Lemaitre's discovery of the Big Bang seemed to kill that idea, because something very strange is happening when you take Einstein's equation and you roll it backwards to the beginning of time, to the Big Bang. You discover indeed that there was a Big Bang, but you discover also that the equation, Einstein's equation, destroys itself. So Lemaitre's discovery seemed to suggest that the Big Bang, the origin of the universe, remained outside the realm of science. And so Einstein lost hope in science providing an ultimate explanation. You might wonder, well, how did Lemaitre really think about it? Did he really want a place for God at the beginning of the world? He did not. In fact, he had a very, very subtle line. I could talk for hours on this. Lemaitre replied that in the absolute simplicity at the beginning of the universe, all physical questions disappear. So somehow Lemaitre had different expectations of what science and cosmology would ultimately be able to tell us about the world. In fact, Lemaitre's conception of the Big Bang resembles to me somewhat Constantin Brancusi's famous egg called The Beginning of the World, incidentally an artwork produced in 1927, exactly the same year as the Lemaitre-Einstein meeting. And likewise, Lemaitre talked about the Big Bang, not in terms of the Big Bang, that term was coined much later, but he talked about the Big Bang as a primeval atom. Here's a graph, which you can find in one of the little notebooks that Lemaitre kept, and all the way at the left, you see, he writes atom. It's a graph that represents the expansion of the universe. But then that atom, what was that atom? What was the primeval atom? Lemaitre never wrote down a single equation as to what that atom at the origin of the universe could be. Even though this was one of the highlights of our 600 years of the University of Leuven, he didn't write down an actual theory for a primeval atom. He viewed it as the origin, he viewed it as part of science. He viewed the beginning as part of science. He thought there could be a theory describing the primeval atom, the origin of the universe. But he also thought, remember his quote, he also had this intuition that even if we had such a theory, it would not provide a real answer to the ultimate cause of the Big Bang. You see, I think Lemaitre's intuition was something like, with the Big Bang, with the origin of time, we may have discovered something that doesn't quite have a cause. That was his intuition. Now, it is, he was way ahead of his time. I will now jump a few decades. In order to describe, in order to model the primeval atom, you had to wait till the great two revolutions of 20th century physics, relativity, gravity, Einstein, space and time, and on the other hand, quantum theory, the microscopic world. You had to wait till we began to see how these two theories could be interwoven and combined, and that only happened much later. But in the end, Lemaitre was roughly right in the sense that we now have observed sort of the remnant heat of the Big Bang, so we now sort of observationally know that the universe must have had some sort of beginning. When you develop such quantum thinking about the universe, that's essentially the core of my work with Hawking, you come to a rather striking conclusion. In fact, It's a model that in many ways incorporates Lemaitre's intuition. So this is how I would visualize, how I would describe the model that Hawking and I developed. We go back in time, to the left, towards the beginning, and instead of hitting a wall, like what you do if you blindly trust Einstein's theory, if you go back in time in quantum thinking, something else happens. You know that quantum theory, the microscopic world, is full of uncertainties, full of blurry, wavy uncertainties. Well, all the way in the beginning of the universe, those uncertainties even act on these very basic notions of space and time. You see there, all the way at the beginning, we sort of lose a clear notion of time and a clear notion of space. They sort of get mingled up. They sort of blur together, which creates the possibility of, I would almost say, rounding off our past. The distinction between space and time, which is crystal clear in our present world, blurs in the earliest stages of the universe. And in fact, that transition, that early stage, that blurring of space and time is the culmination, we believe, of a deeper level of evolution, a level of evolution that is playing out at the level of the laws of physics themselves. We reach a stage in which the structure, the basic structure encoded in the laws of physics, the particles, the forces, space, time, and so forth, that structure unravels, that structure evaporates in a sense. So if I were to give you an abstract picture of these earliest stages of the universe, I would draw it like this. I would draw a tree of laws. Emerging from the Big Bang is a sort of gradually diversification of forces and particles and so forth till we get to the laws of physics. On top of the slide, the laws of physics as we know them today. This is different from how Einstein wanted it. Einstein wanted an ultimate theory, a Platonic truth, a set of prior, immutable, mathematical laws of physics. The picture of the Big Bang that emerges is different. It's much more an evolutionary process in which the first stages of the universe, you really have the gradual diversification, the gradual emergence, I dare say, of the laws of physics as we know them today. So the origin of time that Lemaitre discovered, it seems to me, is not just the origin of the universe. It's not just the origin of time. It's also the origin of physics. The notion of the very laws of physics also seems to evaporate deep into the Big Bang. It is as if the Big Bang is an epistemological horizon, a sort of limit as to what we can know, a limit as to where science reaches. So to summarize, I think about it, this is a sort of a different illustration. On the left, you have Darwin's famous first sketch of the tree of life. On the right, you have Lemaitre's sketch of the expanding universe. For almost a century, we have tried to understand these very different layers of evolution, biology and cosmology, on ontologically different grounds. Biology was all about emergent regularities, emergent laws. Cosmology was always about fixed, immutable, Platonic prior truths. The deeper crux of the hypothesis that Hawking and I developed is that this is misguided, that this was a mistake, that in fact cosmology and biology are on ontologically similar grounds, but we don't notice this because the laws of physics only evolved in the very, very beginning of these cosmological evolution. Then they crystallized when the universe expanded. So if you wish, you can read more about this in my book. On the Origin of Time is, of course, a variation of On the Origin of Species from Darwin. Now you might wonder, well, wait a minute. This tree of physical laws, is this unique? Did it have to be like that? Then we're back to Alicja. Of course not. Much like the tree of life could have turned out completely differently, the tree of physical laws could have turned out differently. The habitability of our universe was not so much encoded all the way in the beginning, but was the result, is an emergent feature of our universe, an emergent quality, just like anything else. In fact, to quote the Belgian poet, one could say that la question de l'origine cache l'origine de la question. And that's a key point. That's a key point. What's happening here in this transition from thinking a la Newton and Einstein about our universe versus the modern quantum way to think about our universe is somewhat of an epistemic readjustment. We are putting our observer's perspective inside the equations, inside our theories. Yeah, so I was reminded of that when walking through Weltenlinie earlier today. If you walk through Alicya's installation there, it's like walking through the history of the world. There's a gradual transition between nature, culture, and all that. But what is most striking to me is that her installation comes to life only through observing, only through walking. It's as if the universe, reality, acquires meaning very much through the interaction, through observations. And that is exactly how quantum theory works. The most fundamental thing that quantum thinking has enabled us to do, I believe, it has enabled us to let go of the age-old Archimedean standpoint onto the cosmos. Newton, Galileo, Einstein were looking for the final objective truths, were trying to put us to take some sort of Archimedean or godlike view onto the cosmos, onto the universe, trying to put ourselves outside. And this was one of the successes of physics. It has led to all sorts of discoveries. But when it comes to this most fundamental question, when it comes to cracking the biophilic properties of the universe, to grasping those, of course it's a mistake to put ourselves outside. Because the biophilic nature of the universe, deep down, is the question, how do we relate to the workings of the cosmos? It's a question about us and the universe, how we relate to both. And so I think the late 20th century and the recent work in cosmology is really about exploring the universe from within. Finally, we are able to put us in the equations. That has far-reaching consequences, I think. I'm not well placed to explore all this. In fact, the point has been made many times before by artists, by philosophers, and so forth. The key, of course, the key novelty here is that we bring in this scientific perspective. The point has certainly been made by Hannah Arendt in her book, The Human Condition, where in the second part of her book, she looks for a trace of the human condition in fundamental science. And she doesn't find it. She doesn't find it because even quantum mechanics at the time in the 50s and the 60s was practiced from an Archimedean godlike view based on repetition and so forth. In many ways, I believe that the hypothesis that Hawking and I developed is a response to Arendt's concern. Arendt was convinced that even the fundamental description in terms of physics of our universe must one way or another include the very basic constatation that we are here, earthly dwellings, looking up and looking out and trying to understand our origins. Now you might wonder, how did Stephen think about this? Hawking certainly started out as a an Einstein, right? Believing that he would soon find the ultimate theory. He writes as much in his book in the 1980s. And so the story of my collaboration with him over 20 years is really the story of how King slowly came to change his mind about some of these fundamental questions. And this is what he told me once we had wrapped up our work shortly before he passed away. So here is, some people will be very disappointed if in the end there is no ultimate theory. I used to belong to that camp. That's the early Hawking, that's the Hawking a la Einstein, looking for a final answer. Here's the later Hawking. I'm now glad that our search for understanding will never come to an end, and that we always have the challenge of new discovery. Without it, we would stagnate. So in a typical Hawkingian fashion, he turns around the search for an ultimate answer to something, well, maybe a more human answer is in the end what suits us better. So why this shift? Well, because of course, if this tree of laws, remember, if we go back into the Big Bang and even the laws of physics disappear, you have some sort of scientific description for how the universe came to be, but your laws, because they disappear into the Big Bang, don't provide the ultimate prior foundation like Einstein would have liked to see. In fact, this quote of Hawking reminded me somewhat, or made me think somewhat, of Alicya's work. If you look well in the exposition, you have to look carefully, because these keys that Alicja puts on the ceiling there, they're sort of a metaphor for this, right? These keys seem to offer a solution for a problem we don't know, and they certainly imply the existence of knowledge that may forever remain out of reach. I think this is a fairly nice summary of the equation that we wrote down. We have an equation that includes us, but if you use the equation to go back to the Big Bang, the equation itself sort of evaporates. In the last couple of minutes, I want to challenge Alicja a bit and look to the future, because the story is not over. Here's the history of the universe. The Big Bang is on the left, we are on the right. And now the key question is, well, how do we get all the way back to the Big Bang? How do we get fossils of these earliest stages of evolution in which even the laws of physics evolve? How do we gain some observational evidence? How do we learn more about this? How do we test a theory of the Big Bang? We cannot do this with any normal telescope. Why? Because the furthest light that can reach us is emitted 300,000 years after the Big Bang, when the universe expands, becomes large, and becomes transparent. The earliest stages of evolution of our universe are in the mist. They're hidden. It's like trying to look inside the sun. It's impossible. The photons bump into one another all the time. But we happen to live in an era in which a totally new window opens up, a totally new way to explore the universe is opening up. And that is not through the observation of light of various frequencies, but that is through the observation of what is called gravitational waves, ripples of Einstein's fabric of space. Now, those gravitational waves, they go through everything. They even go right through these dense, hot regions of the early universe. They, in principle, observations of gravitational waves, in principle allow us to reconstruct the history of the universe all the way back to the Big Bang. So this is a very special era. It's like the birth of a new kind of astronomy. These days, if we astronomers look at the sky, it's not just light. It's like opening up, it's like hearing the universe. These are the bursts of gravitational waves coming from collisions of black holes through an observing run, and that's how we now look at the universe. We see galaxies, we see stars, but we hear the collisions of the dark side of the universe. Black holes colliding, galaxies colliding, stars colliding, and so forth. And you see, it goes even, black holes keep colliding all the way through COVID. But this is only the beginning. What's happening, so far we have not observed gravitational waves from the earliest stages of the universe. So far we have observed gravitational waves from, say, our cosmic neighborhood. But what's happening is that there are two projects on the way to be launched in about 10 years from now, to be two great observatories for gravitational waves, which will really enable us to take this revolution forward. One is a project of the European Space Agency. It consists of 3 satellites forming a triangle, each side 2 million kilometers. This is the biggest experiment ever conceived. That triangle will move with us around the sun. When gravitational waves pass our solar system, the 3 satellites will move ever so slightly with respect to one another. We will be able to read the universe through gravitational waves. And it has a sister experiment down on Earth here, called Einstein telescope. Once again, a triangle with laser beams monitoring the distance between the 3 corner points, waiting. It's like a trap for gravitational waves. You just wait and listen to the sound of gravitational waves. And together, so up in space and down here on Earth, what is going to happen in the 21st century, we're going to reconstruct the history of the universe through observations of gravitational waves through the dark side, all the way back to the Big Bang. And the reason many of you will have heard about Einstein telescope is, of course, because here in our region is a bit of a special case. This is a picture of the so-called Euregio-Meuse-Rhine. If you look carefully, you see it's the border region between Belgium, the Netherlands, and Germany. And in the middle of this region happens to be a rock, a solid rock deep underground, which is suitable to construct the Einstein telescope, and hence, of course, all the interest of the various politicians and so forth. It's a big science experiment, never undertaken on this scale in Belgium. And so we're involved in this here in Leuven. It's really the next chapter, I think, in our adventures here in Leuven. So this is what I wanted to tell you. This whole story, we started out with a mathematical equation, and we are ending up 100 years later with a big science experiment. And this is a huge dialogue. It's a dialogue across generations, across nations. In fact, I think it's pretty much the best humanity has to offer. But we're not ready with this scientific revolution. As I hope I explained you, we do not know what fundamentally science and cosmology find out about the universe. And we're not going to build Einstein telescope or the space experiment without a broader scientific culture behind us. This is far beyond just science. This is really about society more generally, socio-economic aspects, educational aspects, scientific culture. And so that's a whole new layer in which I think also science and art and their dialogue can be certainly of much value. So thanks a lot.
Are we set to start?
I'm not sure.
Okay,
Yeah.
great. So, I think we are all like supercharged now with this talk. I think it was like mind-blowing. I don't know what you think, but you know, like it gives so many insight, and I don't know if it gives hope, but it gives at least
Confusion.
Food for thoughts, definitely. So thank you very much for enlightening us on this amazing research and how, you know, the 20th century basically was shaped with these equations. I'm wondering. I had the first thought how to start this conversation, but I keep wondering in my mind, you know, like, because we talk a little bit about this when Einstein discovered this equation and how it shaped the world. It was exactly at the same time also as the artist has more or less the same intuition, you know, like we're talking about the surrealism, the starting point of abstraction, and basically the abandon of the idea of what we know of this world. And of course the surrealists were looking for something else, but basically it was clear that at that time, exactly at that time of Einstein, there was this idea of that the world should be much broader than the one that we know. So you'd say in 10 years we'll know more about our universe, and of course I'm wondering how it could be translated in artist thoughts in 10 years. So that's the pending question I have, maybe or will have through the conversation. But I'd like to start the conversation with this cast of dice. I think it's very interesting. It's how the exhibition starts. And of course, I immediately thought about Mallarmé's quote, you know, like in this famous poem, he says that a cast of dice will never abolish chance. And I think this is very interesting because, of course, Mallarmé's poem was written, I think, in 1897, so way before quantum mechanics, way before contemporary cosmology, way before even the idea of time as we know it today, or as we don't know it today, which is very interesting because, you know, the idea of time, I think the more it evolved, the more we realize it might not be what it is. So this is my first question about this work that, you know, like basically welcomes you in the show. How do you imagine chance? What's the status of chance? Maybe not in terms of its existence, but mainly where does chance exist? And I think I will start with Alicia, because as an artist, of course, chance is always something you have to embrace. We know as artists there is no way to control things. You have to have a system, but in this system you have to build in such a way that chance is basically one of the main character. So how, by doing this work, for example, and I was surprised to learn actually that it's not like a recent work, but something you exhibit like 15 years ago, something like this. And how do you see nowadays with all the experience you have?
Thanks, first of all, Marc-Olivier, for opening up this talk here, and thank you for the mind-blowing talk. Yeah, it's kind of hard for an artist to talk about their own art. It kind of feels a bit strange, but I'm going to try my best. So, so I can kind of describe why I'm doing things. I cannot really describe you what I'm doing, I think, but I try to explain what kind of my motivation is somehow, not even motivation, but my kind of starting point. And as you just mentioned, this work is quite an older work, but my kind of work in the themes never really changed. I think I'm, from the very beginning, driven by probably even similar questions as you are. Just somehow I have a very different approach to it. So for me it was always about a very old human question: why? Why is it? Why is it what it is? Why I believe to be here, why I believe to talk and see other faces, why I believe the space to be a space, the building a building, the planet a planet, and so on. So that always been the same thing. But kind of getting to your question, how kind of chance is a part of my work, but kind of trying to wrap it up in our conversation here. It's like what I do is like a mix of, how to say, it's a mix of research about things I do not understand and I desire to understand deeply. So, and I'm not educated in any science at all, which I try to take as a benefit for my own work. So the failure in it is already kind of, this is my starting point. So back then, and still not that much anymore, unfortunately, but I was trying to read a lot about quantum physics and this and that, and not understanding anything of it in the way as a scientist would do it for sure, but trying to make it understandable for myself somehow. So this is kind of where what is somehow my source, or not my source of, yes, it is not my source of inspiration, because inspiration is a question, but this is kind of my tools to help myself to understand. And then, of course, the chance, what you call chance, it's more something between an intuition somehow, which as an artist, it's probably, for many artists, it's kind of the main tool. I try to reduce it sometimes even, as much as I can, because I try to somehow see myself as one of many. It's kind of hard to explain, but so I don't try to make it kind of too personal in a way, even that I know it is. So it's kind of a mix of, of a emotional state and a very precise research, and try to explain it to myself and to make it visible for myself in the way of my not thinking, of my not understanding, probably, or my open questions.
Okay, yeah, thank you. And Thomas, where does chance stand in your models? What do you do with chance? Where do you put it? Do you even integrate it somewhere?
Yeah, I think much of the 20th century physics is the gradual realization and attempts to give to chance, accidents, a proper place within physical theories and cosmological theories. In 1897, physics was all about determinism, predictability, certainties. It's only with the advent of quantum theory that physics became, that chance and unpredictability and probabilities became all over physics. Einstein famously objected, God does not play dice, he said. I think this is the evolution. And now, gradually, in the later stages of the 20th century, that's what I described, chance even is integrated fundamentally in our cosmological theories. The history of the universe could have turned out completely differently, even at the level of the laws of physics. So we can only sort of work backwards, retrospectively reconstruct it, just like we reconstruct the tree of life.
Yeah, and Alicia, we're talking about intuition, and I would like to hear about how scientists are integrating also intuition in their work, because it sounds a little bit counterintuitive. We think of scientists having a very, very well structure of thoughts they apply, but I know sometimes it doesn't work like that. I mean, sometimes intuition are really part of the process, like artists.
Yeah, most of the time it doesn't work like that. I guess when you construct new physical theories, like this equation that Einstein wrote down, it took him 8 years. So one might wonder, what was he doing all these 8 years? He describes it himself as a journey through the desert, not knowing where he would end up. So I think he was guided by, not equations, right? He was guided by one intuition as to what could be more fundamental principles on which physical theories could be based, and secondly, in consistency of mathematics. So it's never just intuition. It's always, you're trying to ground your intuition in a consistent, coherent mathematical framework. And okay, that took Einstein 8 years for these theories. So I would say it's intuition, but with boundaries, framed. But then there's the whole spectrum, right? For instance, Hawking was famously on the intuitive side. He couldn't write himself, so he developed his own sort of way of doing physics, which was a little more intuitive than all his colleagues wanted. So people were outraged when Hawking, using his intuitive style, came to discover all sorts of things which people couldn't find in their equations, to Hawking's delight.
So intuition is the characteristic of a talented researcher, you think? Or?
I think it's a way of life, almost, yeah.
So Alicia, I'd like to hear something about tensions. I think there is tensions in the universe, as we understood. But in your exhibition, it's really clear that tension is one of the key architect of the exhibition. I mean, like there is like heavy stones. You feel they're like floating. Clocks are running backwards. Objects seems like they're like even like copied, or they are like in a representation because they're in front of a mirror. So you never know where is the original. There is always this tension between what you see, what you feel, and this is for me extremely interesting because there could be no tension in a way. We build this tension because we have these expectations. We think that a clock, I mean, is always going in one direction, and even if it gives the exact time, if a clock's going backwards at some point, we feel tension, and I think also we feel tension because we might have the answer at the tip of the tongue. You know, it's like, oh yes, it might be that, but each time it escapes us. Is it something you have in mind when you think about a new piece?
It's not really, if I understand you right, that tension is like for you kind of this, let's say, this border between two things, or like say tension between your expectation and what you see or what you believe. I never have that as a starting point for work, because how a work actually appears is not that you don't have like a plan from A to Z. So there's nothing I really kind of expect the work to do, and sometimes I'm surprised what it does in the end. But of course, I have my own thinking about that, and this is mostly the not believing. So it's more that I hardly believe when I think about it, and I have a little bit knowledge of those things, much less that somebody who's educated in that. It's hardly even to believe that I sit on the sofa right now, because I know that it's actually not much matter in the sofa. So, but I still have to believe that my nerves and my legs are feeling the tension of the sofa now. So I believe that I'm here and I'm sitting here. And I kind of don't believe things somehow. I don't believe that, what means the belief? I'm just questioning if the object I do see is the object I believe it because I was educated that I describe a chunk of compressed ground as a stone, for example, and I would not describe a mountain as a stone and not a little stone, which I found on the... So I have to... I'm kind of aware of the fact that I'm giving, that I was given informations, I learned things, I accepted things, and that's why I believe that I see the world as I see it. But I indeed do not believe it. So I kind of try to figure out why I believe that and what the borders of that are. And I try to question simple things, like why do I think that I see what I see? Why do I think that things behave in a certain way? Why do I think that a piece of glass is sharp just because I'm soft? Why I'm soft? And what is kind of this tension between the objects? Me as the observer and the physical object and the world around me. And that's actually what I'm trying to do, especially also, which is quite obvious with the piece with the mirrors. It's like, it very much depends on your point of view as well, where you are and from where you look at things. And I mean, and not taking in now all the social back structure, I mean, how we are educated and where we are educated and stuff like that. But it's more like really like questioning the given, questioning and looking back, like also the clock, why is the clock like a clock? Nobody, I mean, this is like a simple example. Why have we decided for this 12 numbers? Why is it going to the right and not to the left? And kind of looking to, in those making of the object. So why, and the acceptance of the object, which when you look at it deeply, you do not always just end up in physics, but also in politics, in social structures. I mean, the clock is going to the right because it was seen from the northern hemisphere. Why was it seen from the northern hemisphere? Because the northern hemisphere back then was more powerful of seeing itself as the leading, so there's so many structures under every little thing, which we kind of accept each day, which we just kind of accept because it's easier to accept things and to kind of be guided than not. And I think this is, if I'm explaining it right, this is kind of this permanent, doubt about the truth of things somehow.
Yeah, so that's very interesting because, of course, I believe, and you're totally right, that a good artist is always questioning things. Like he wakes up in the morning and he's doing his job, which is questioning what he has around him or her, and that's the key thing for an artist in order to do something with that. So about questioning, I think, of course, in science you have to always question things. But in a way, I mean, you have to question, I mean, that's my question, do you have to question things with the language you have in hands? Or can you invent, I mean, you're talking about Newton who had to invent a new language to go forward with these theories, but as a scientist, which language do you use in order to question things? Or you use what is at hand and the principles of mathematics and physics?
Yeah, I guess the language of science happens to be fundamentally mathematics, right? And the magic of that has been that when you succeed in transforming your intuition in some sort of coherent mathematical framework, the equation, Einstein's equation, for instance, the mathematics, opens up new doors, really reveals a new reality which you had not thought about and which you may or may not accept. Einstein famously did not accept the consequences of his own equation. So I think fundamentally mathematics has been the language of science. Now about structures, that's an interesting story. You mentioned Newton. Yes, Newton in the first half of his famous book, the Principia, develops mathematics because otherwise he couldn't do physics. So he had to invent the calculus. But Newton, in the first part of the Principia, also puts down a lot of structures, which he takes for granted. Time is absolute, space is absolute, matter is this and that. And you could conceive of the evolution of physics from Newton to today as gradually taking away these structures of absolutes, these structures, these features of reality which we take for granted. Less and less is certain. Also in my story, right, you go back to the Big Bang and even the notions of particles and matter and space and time disappear. So what is the end point? I think the end point is a physical theory, a cosmology, so to speak, with no structure of absolutes behind it.
But that's mind-blowing, but what do you do once you discover that? Because this is very interesting, because, I mean, it's totally pataphysical, but for me, like, I have a way to examine or judge, with all quotation marks, an artwork, and I develop which is like this totally like pataphysical a thing, which is the schizophrenic quotient of the artwork. So schizophrenic quotient, the higher the quotient is, the better it is. So I would say that a table, for example, is like one interpretation. You have one use. A designed table is maybe 2 or 3 interpretation. Maybe an artwork starts at 4 or 5 interpretation, and then a good artwork might start at 10 or 15, and then of course a masterpiece, like, you know, like infinity. And of course, in that theory, the best artist is of course Marcel Duchamp, because as we know, each generation comes with new interpretation, and that's endless. But in science, you cannot do that, no? Or, I mean, can you develop an object of or research that has a higher schizophrenic quotient? that you wouldn't be accepted by your peers, no? Or, because it seems that it might happen if time doesn't have the structure we expect, if space doesn't have the structure we expect, if gravity is something we will discover with new structure, everything is going to evolve with new interpretation, and the interpretation is endless. Where do you stand? It's not so much, I think, if I understand you well, I don't think it's a lot about interpretation. I was mostly referring to sort of the structure of absolutes, the metaphysical structure within which you do science. That tends to, the evolution of physics is to sort of eat away that structure and have almost nothing as prior truths. I don't think the interpretation is up for grabs. In my experience, there's a lot of confusion in the scientific community. There was a lot of confusion about Einstein's equation. There was a lot of confusion about quantum mechanics. There's still confusion, but gradually a consensus emerges on the interpretation of how we should think about. We're not there yet in terms of quantum mechanics. But I don't think the interpretation is no. You can't have. But interpretation has possibilities. Sure. Of course. Sure. Yeah. The notion of reality that emerges from modern cosmology and physics is very much one in which. It really describes reality as some sort of space of possibilities. Determinism, like Newton would have it, or in the 19th century, that is really far behind us. Yeah, that's right. So I'm wondering with this idea of like endless possibilities, and of course, which is at the heart of quantum physics, and I think at the heart of the way we think about, or we might think about, a good artwork. I take, for example, for me, why I think art is important, and the question is for Alicia also. I think why art is important, especially nowadays, is because it gives you a kind of like mental hygiene, which means we are surrounded by images, we have to deal with that. How do we deal with all this material? And I think museums, for example, are playing a crucial role. I think they play an even more crucial in the future, in such a way that it teaches us how to deal with images. And an artist that wakes up every morning by questioning his surrounding and reality, I think he is a very good tutor for every one of us to teach us how to deal with our everyday life. What do you think, Alicia? And then I will ask the same question for cosmologists and physicists, what it can bring to nowadays reality.
Of course, I don't have an answer for that really, because I don't, it's not, of course, it's a questioning, but of course, it's a very different approach still. I think even if there's some similarities, I think how artists mostly work. But I indeed believe that somehow, art is not like a thing beside our daily lives or society. It's one part. It's one part of our try to understand what that is, without the need to speak it out, without a need to write a sentence. Until you're a poet and you need to write. But kind of this is somehow the benefit that it's more like it's really hard to explain it, but it's more like a distillate of a feeling or of a circumstance or of a time. But it does not need proof. It's like most things in life. I mean, they don't have a proof. There's not like a right or wrong really when you look in things very deeply sometimes. And it's more like also trying to kind of solve those very human questions like science is also kind of looking for, which is, I think, in the very core of the human being. I mean, it's like this, not that I'm a big fan, but Arthur Schopenhauer said it very well once. He was calling like the human beings animal metaphysicum, which means like the only creature on this planet who is suffering of the self-being, looking, like trying to look beyond the stars without being kind of able to do that. So just to short it up, I think that it has the same value, both, looking in different ways on those circumstances which we are all thrown in. I mean, we are sharing a little spinning sphere all together, and we are kind of trying to figure out why that is. And I think there's different approaches to get to an understanding, and not always like measurable knowledge is probably the answer. It's one way to answer it, yes. But people have different sensors and different sensibilities to kind of get sense in that, or get like like something like an understanding of why we are all here, because this is one thing which we are all sharing, that we have no clue, nobody ever, and this is kind of a problem which we are kind of trying to solve from all sides. And I think it should be also seen as an equal thing, and also art should be even more in society than it is now. And so I'm happy that museums like this one is also doing quite a lot of work to kind of, to give people the chance to get in it, and not to kind of feel like they don't belong to this kind of discourse. Because art, from the very beginning of our beings, has been always an important part of our evolution and of what we do as humans.
Thomas, the idea of looking at the world in a specific way might help everyone to see, or might be a toolbox, might be a toolbox for everyone that could be healthy in a way to look at the reality that surrounds us. I mean, the idea of possibilities, for example, I think that's very interesting. If you look at the world as possibilities and not right, wrong, or like there, not there. If everything is a possibility, then you start looking at the world differently. Of course, you have to build, everything might be equal, but you have to set some distinction in order to navigate in the reality. But do you think seeing the world and the universe as you try to do every day could be also very helpful and bring a kind of a toolbox for our everyday life?
Oof. I'm biased, I guess. Well, on the one hand, it's enriching and frankly mind-boggling the extent to which science, physics, cosmology, biology enables us to sort of rethink our place in the universe, our worldview, and so forth. And yeah, thinking about the world in terms of an ocean of possibilities is perhaps one thing. On the other hand, science only gets you so far. And by that I mean what we do with that knowledge goes far beyond what the equations are telling us, of course. That's, in my view, where we need a firm embedding. That's what I often call, we need a scientific culture. And a scientific culture is enriched by, of course, scientific discoveries, but equally well by art, by literature, by music, by all sorts of spheres. It's really this palette of reflections which frankly share a common root. We all, as Alicia was saying, we start from the very same questions, but we go about them in a very different way. In the end, in our society, in who we are, all these different spheres come together again. And I think this is often forgotten. Science has become so powerful, so dominant, and sometimes in the wrong way, in the sense that it provides certainties, answers, objective truths, and so forth, that I think we need to strengthen the broader scientific culture if we are to figure out what are we going to do with all that knowledge.
But I also think, Marc-Olivier, that, I don't know, I mean, whenever I'm trying to understand, like, science, let's say, it's kind of hard to say it even like that, but whenever I look at this, because this is things which, of course, you know, like, concern us all, because it's the thing we are working on, and, you know, and we are getting forward that, but also, for me, there is so much, like, when I try to understand it, so much abstraction and beauty in it. So I'm so kind of glad for those pictures which that is kind of creating in my head whenever I try to read about quantum physics or something like that, because it's like a chaotic wonderland. It's like insane. It's like more than I think a normal brain can kind of get somehow. And this kind of shifts again to, I'm not saying that is art, but somehow, I mean, art is also made from the same thing, you know? It's also somehow made in the stars, if you want. I mean, it's physically, you know, I mean, we are kind of in the same, well, it's all made from the same thing. But for me, there's like I don't know, there's somehow like another layer of overlapping, and probably we should not even try to divide it so much. Of course, there's a very different approach, and like proving, not proving, you know, like making a straight kind of way to something and not. But yeah, I think there's also like another layer which probably should be more underlined.
Well, physicists often talk about beauty in their equations, so we certainly use the same terms. But still, the scientific methodology is there.
No, I'm not doubting that. I'm just saying that all the people who are not, you know, in science, I mean, kind of the possibility to get access to that can inspire you on very different levels. And this does not need to be right in the sense of
but that's the
right,
thing,
right.
You know, with science for like Beotian like us, we sometimes see things in science and we think, oh, that's fantastic, but because we don't understand. And it's like art.
That's
you know?
A good thing.
Art. Imagine art if you understand art. You know, you see an artwork, it's oh yeah, I understand it. then it becomes boring. You know, there is no tension, there's nothing you can do with it. You know, the day after it seems still the same. And but a good artwork, you know, like if it has a network of interpretation, or at least something you don't know, or you might know, or there's this tension of truth coming up but never be revealed. And for us, at least, sometimes science is magical because we see the beauty in it, but of course we don't understand it. So it's still kind of like in the magic realm.
Well, I can assure you that
but my
it's
question
beautiful
is,
also when you understand it.
Probably even more.
My passion is really trying to see all these fields of knowledge. You mentioned it. And we talked about the zeitgeist, and trying to grasp this zeitgeist nowadays. What's the state of, or the latest research in science, the latest research even in archaeology. For example, in my museum we have a big department of archaeology, and it's very interesting to see that what you search in archaeology is totally different of what you searched 1 century ago. Why? Because we are looking for different things.
Right,
you know?
but one thing about the zeitgeist which we cannot ignore, I think, is the emergence of artificial intelligence.
Yeah.
Can AI come up with a new kind of physics which we may not be able to grasp, neither accept? That's, to me, the key question.
But is it, sorry, I have to go back to Newton for a second, because there was like this talk about that he reinvented or invented math in another way.
He invented a new branch of mathematics, calculus.
Okay. And this is probably what's going to come with KI as well.
That's right. Yeah. Except AI does not like the kind of physics we have known since Newton. AI does not tend to work with equations. It comes to regularities and patterns in a completely different way. In fact, rather in a black box way. So if AI reaches the stage, which it might do in 2026, in which it enables really conceptual thinking, I have no clue what kind of physics it would come up with.
But sorry, but last question. But you say, okay, mathematics is your tool, right? That's a tool you use.
Yes.
That's your main tool.
It's Newton's fault. Right.
Yeah. But so in this case, it also not might be right, or is it? Is there like a?
You mean, is mathematics the true language of physics?
No, I know that you said it is.
Well, it's a true language of human physics, yes.
Yes, but yet getting back from Newton to KI again, so it might be the case that your most important tool and your truth also might be wrong, or not?
Yes.
Right. Okay. I'm just trying to. Okay.
I'm not sure what's wrong and right here.
No. It's just because I've been like more swimming more about post-optional, you know. But you're kind of guiding back to, of course, how you work and how the consequences in science of course are, and this is based on this kind of common sense of mathematics as it is. That's why I'm just wondering, okay, if that is probably wrong is the wrong word,
yes,
right?
Yes,
but probably if this is, let's say, not describing what you are trying to describe, means you have kind of the wrong tool, but you are trying to describe
the real world.
The real world, which is okay, but I just,
I think it's okay. It's the best we can do. But it may not be the...
But it's not, there's no doubt. I mean, you have no other way, anyways.
I really don't know what... Yeah, we have no other way. And I think it raises a fundamental question. Is science ultimately about understanding? In that case, I think mathematics for humans will remain a prominent tool. Or is science about a tool just like biologists now use AI as a tool to predict protein folding and develop new medicines. But imagine doing the same kind of thing at the level of Einstein's relativity. I have no clue how it would work and whether we would be satisfied with it.
No, that's a very important question. I mean, if we think about the zeitgeist, of course, we have to integrate it.
Yeah.
But just, I'm thinking about, like once I was talking, my neighbor was a very high-end mathematician and a specialist of topology, and I, we had this conversation, and of course I had this idea of mathematician is even right or wrong, and said, no, I'm not at all. I mean, for me, it's not the problem. An equation is, or a math operation is useful or not useful. And I think, I don't know if we can apply the same approach to AI, but that's a tool. It's a tool that works on probabilities. So one day it might be useful, the other day even the same answer might be useful, the day after it's different. But if we apply this with our mental hygiene, like at least for what I know, given by the artist, where if you see the world with questioning and always questioning your surrounding, what does it tell about the zeitgeist once again? So for me, it's very interesting to talk about art, science tonight, and we can integrate everything in it. We can integrate sport, we can integrate science fiction, we can integrate whatever fields of knowledge, and trying to see what light it could cast on our surrounding. And I think that's the main, for me, the main interest of the tool provided by scientists, by artists, and everyone, is just for us, what can we do with that in our everyday life? And again, about possibilities and is it useful or not? I don't know if we can end this talk on that.
I have a last
note.
question, Thomas, sorry. But I always wonder, when I see those graphs about the Big Bang, for example, you always have those graphs, and I always wonder, what do you do with the space behind it, around it?
Oh, Einstein solved that. It's metaphysics. The universe is not expanding into something. It's described as it is from within. What is before the Big Bang or what is outside our universe does not enter into this wonderfully beautiful equation that Einstein wrote down. It gives an
is it a
intrinsic
question?
description.
I mean, is it questioned at all, or is it too far because it's not observable? It's not. So we better not.
Right. It's not observable, and it does not enter in the equation or in the theory. The equation does not require anything outside the universe. That's the invention of 19th century mathematics, Gauss, and those people who provided a new way of geometry, a new way of describing the universe intrinsically, without reference to a structure beyond or outside it. So that came in very handy.
Thank you. Thank you very much, Alicia. Thank you, Thomas.
Thank you for guiding us.
I don't know if there is any room for questions. I don't know if it might be interesting. I'm sure you have many questions. I still have, but we have to end at some point. Should I give my mic to someone? If not, we're very happy to be with you tonight. Maybe you'll have some questions later. So thank you very much. Thank you, Alicia. Thank you, Thomas. Thank you, everyone, for being here tonight.